How do you find the vertical asymptotes of a function? And we're going to look at several examples in this video, and all the examples will be rational functions, so functions that are a polynomial divided by a polynomial. And let me just say, it's helpful if your function is written in factored form. If it's not in factored form, you're going to have to factor it. So let's look at this first example. F of x equals x plus 3 times x minus 1 over all this right here. What are the vertical asymptotes? Well, any number that makes the denominator be 0 is going to be a place where the function is undefined. Now, it could be undefined for one of two reasons. It could either be a vertical asymptote at that value, or there could be a hole in the graph. And how do you tell? Well, at x equals 4, right, when we plug in 4, we get 0 down here. We're going to have a vertical asymptote, and that's because we don't have an x minus 4 factor up here. So we'll have a vertical asymptote at x equals 4. We'll have another one, x equals minus 2. And another one, x equals 7. But at x equals 1, since we have x minus 1 here and x minus 1 there, we're going to get a hole in the graph at x equals 1. Now, let me just say, really, for vertical asymptotes, you should put more than just 4 or negative 2 or 7. You should put x equals, because a vertical asymptote is really a vertical line. And the equation of a vertical line is always x equals something, just like a horizontal line is always y equals something. So write it as x equals 4, x equals minus 2, and x equals 7. Those are the vertical asymptotes. Now let's actually look at the graph of this in Desmos. So I've graphed it here. Here's our function f of x. Notice that we have a vertical asymptote at x equals 4. I can even type it in here. X equals 4. Notice that gives us a vertical asymptote. Okay, we also have one at minus 2. X equals minus 2. And we have another one at x equals 7. Okay, now at 1, we don't have a vertical asymptote. Okay, what is happening at 1? Well, at 1, let me get the rest of these asymptotes in. At 1, we actually have a hole in the graph. Okay, notice that it says 1 undefined. Now, Desmos doesn't really show you the hole when you draw it in, but there's a way to kind of force make what the hole is, but it's a little tricky to do. But anyways, there's a hole in the graph there at 1, not a vertical asymptote. So again, that x minus 1 factor canceled with something up there, so we get a hole in the graph rather than an asymptote. Okay, let's look at another example. F of x equals x plus 3 over x times x plus 3 times x minus 8. Now, we're going to get a hole in the graph at x equals negative 3. Okay, there'll be a hole in the graph. Now, what are the other ones? Well, we'll have x equals 8 is a vertical asymptote. What about this right here, x? Well, remember, we're trying to figure out what values of x make the denominator be 0. They would be 8, right? If you plug in 8 there, that becomes 0. If you plug in negative 3, that becomes 0. What do you plug in here that would make that be 0? Well, it's x equals 0. Okay, x equals 0, which is really the y-axis, right? The y-axis would be x equals 0. That vertical line would be a vertical asymptote of the graph of that function. Okay, let's do another example. This one right here. Now, what are the vertical asymptotes? What are the holes in the graph? Well, again, look at the denominator. We have x equals 3 is going to be a hole in the graph. I'm sorry. X equals 3 is going to be a vertical asymptote of the graph. What about negative 4? Well, notice this will cancel with this, but we still have one left over down here. And so we're not just going to get a hole in the graph. The fact that even after canceling these, we still have one more left there, that means that x equals negative 4 is going to be a vertical asymptote. Okay, so we have x equals 3 and x equals negative 4. And what about this? Are we going to get like 5 or negative 5? Will that be the vertical asymptote? Well, again, what value of x makes this be 0? What value can you plug in? Well, 0 itself. You can think of it as 5 times x minus 0. Right? So it's x equals 0. Again, the y-axis will be a vertical asymptote. Now, what are the holes in the graph? Well, there's actually no holes in the graph. So I should put none right here. Okay, no holes in the graph for this function. Now, you might wonder, what about this x plus 19? Well, what that really tells you is that negative 19 is going to be a 0 of the function. If you were to look at what's f of negative 19, the output would be 0. If you plug in negative 19 there, in fact, everywhere you see an x, you'll get 0 on the top and you'll get some number on the bottom, but 0 divided by whatever that number is will be 0. Okay, so these numbers don't up here are not going to give you the vertical asymptotes or holes in the graph. Those give you the zeros. Now, one might cancel, and in that case, it won't give you a 0. But okay, now what about this one? I gave you this one not in factored form, so how do we find the vertical asymptotes? Well, we have to factor it. Okay, so let's factor, and we're going to factor both the numerator and the denominator. Now the numerator, there's an x in both terms, so let's factor out the x. It factors to be x times x minus 7. In the denominator, all the terms also have an x, so we have x times, and let's write it out, it'd be x squared plus 7x plus 10. And now let's factor the denominator even further. So we still have our x times x minus 7 up here. We have x down there. And let's see, how will this factor? I believe it factors to x plus 5 times x plus 2. Okay, x squared. Then we'd have a 5x and a 2x would give you 7x, and 5 times 2 is 10. Okay, so notice in the denominator here, what are our zeros of the denominator? Well, we have 0, we have -5, and we have -2. So which ones are which? Well, at 0, we also have the x factor up there, so we're going to get a hole in the graph at x equals 0. We're going to have vertical asymptotes at x equals -5 and x equals -2. Okay, so again, any value of x that makes the denominator be 0 will be a place where the function is undefined. And it'll either be undefined because it has a vertical asymptote or because it has a hole in the graph. And it will have a vertical asymptote if, after canceling all the common factors, if you still have more of those factors down here, that's going to give you a vertical asymptote. Okay, but if all of the factors of it cancel with something up here, like this x cancels with this x, that means that 0 is not going to be a vertical asymptote, but it's going to be a hole in the graph. Now, in a case like this, after canceling, we still have that x plus 4 factor in the denominator, so we're going to get x equals -4 will be a vertical asymptote of the graph.